Wonderful job on Unit 1 with our expressions. You'll see as we start Unit 2 that these expressions are going to carry over into our entire year. So it was super important that we took that time in Unit 1 to kind of brush up these skills so that we can start today on our Unit 2 solving equations. So we'll see this unit. We're going to focus on our first learning target here. I can solve two-step equations today. So a little bit of this should be review from middle school math too, but some of this will definitely feel new. So my first question is, how did this person solve these? So take a second and look at these three problems. How in the world did this person solve these? So we'll find in this unit, showing your work and the steps from the problem to the answer are more important even than the answer in this unit. So we'll see here in this one, all of the answers are given, and we have to kind of think of what do I plug in for X or M or W for this equation to be true. So for example, in this first one, when I plug in 4 for X, 4 plus 3 equals 7. So here's what our steps might look like. First off, we're going to put a line down the equal sign because whatever we do on one side of the equation, we have to do on the other. So this first one here, I might minus 3 from both sides or think that in my head here to get X equals 4. This next one here, I need to think of 4 times what gives us 12. The other thing I could do is I could get rid of this 4 by dividing by 4. And that'll give me my M equals 3. And my last one here, something divided by -2 gives us -7. So we'll find 14's our answer, but to get rid of a divide by -2, we're going to do the opposite, which brings us to that answer. So again, more importantly today, as we're doing these types of problems, these middle steps are more important than our actual answers here at the end. So showing our steps, writing these pieces out, we're going to get to problems that we can't just do in our heads like these ones, where we're going to have multiple steps. So we want to get in the habit now. So let's first remind ourselves, what did we do here to get that letter by itself? In order to get the variable by itself, we need to undo the original operations. So for example, if we see a plus sign, the opposite of plus, or the inverse is another word for that, would be minus. The opposite of minus is plus. Opposite of times is divide. Therefore, opposite of divide is times. Opposite of squared is square root. So let's put these inverse operations. My inverse operation of plus. So again, these are not in your notes. I want you to pay super close attention to how I'm showing my work on these problems. So first thing I'm going to do, down my equal sign, I'm going to put a big line to kind of separate my problem in half, showing whatever I do on one side of this line, I need to do on the other side. So I'm trying to get M by itself. To get M by itself, I have a plus 12 in the way right now, is minus. So the opposite of plus 12 is minus 12 on both sides. Notice how I wrote that step on both sides of the line, and I drew a line underneath showing now I'm going to simplify. So I'm going to have M equals 10 take away 12 is -2, because positive 12 and -12 went away. So here's my answer, but all of these steps showing the work is more important than the answer in these problems. Now, how can we check this? Well, if we take -2 and we put this back in for M, -2 plus 12 equals 10. -2 plus 12 is 10. 10 equals 10. This is definitely true. So as long as we get that true statement, we can always check our answers in this unit. Let's try this one again. A line down the problem to split this in half. We're trying to solve for G. Right now I have a -9 in the way of G. So we need to go ahead and plus 9 on both sides to get G by itself. So -2 plus 9 is positive 7. G minus 9 plus 9 goes away. So we get G equals 7. So again, we're showing all of our work. Now we can check this by plugging 7 back in for G. Do we get a true statement? Negative 2 equals 7 take away 9. 7 take away 9 is negative 2. So we did solve this problem correctly. G is 7. So at this point, knowing how to check your problem and show your work is just as important as that final answer. So let's try some different examples. Now we're looking at two-step. We were just working on some one-step equations. So now we have 2 steps to get to our final answer. Drawing my line. I want to see all of this work in your note packets as well. So drawing my line, we're trying to solve for x. So very first, as we solve for x, we typically want to get rid of the thing that's not exactly touching our x. So in this case, I have a times 6 and I have a plus 8. We're going to go ahead and get rid of that plus 8 first by minusing 8 on both sides. So showing these steps. Now we're going to simplify. I had a plus 8 minus 8, which goes away, leaving me with just 6x on this left-hand side. 50 take away 8 leaves us with 42. Now we're trying to get x by itself, and right now I have a times 6 with my x. So to get rid of times 6, we're going to divide by 6. Now we'll simplify. X equals 42 divided by 6 is 7. So here's my answer. Now let's check this by plugging 7 back in for x. So 6 times 7 plus 8 equals 50. 6 times 7 is 42. 42 plus 8 is 50. So yes, 50 equals 50. True. 7 works. So again, not only doing the problem, but let's check these today. Okay, next one here. We're trying to get x by itself. So that times 2 we'll get rid of last. Let's worry about getting rid of this minus 5 first. So to get rid of minus 5, we're going to go ahead and do the opposite, which is plus 5 to both sides. Leaving me on the left with 2 x's because minus 5 and plus 5 went away. 11 plus 5 is 16. Now we want to get rid of times 2, so we'll divide by 2 on both sides. Leaving me with x equals 8. Now we want to check this by plugging this in for x to see if we solve this correctly. So really nice in equations that we can always check our answers. So 2 times 8 is 16. 16 minus 5 is 11. 11 equals 11. This is true. It did work, which means our answer is correct. Let's try our next one, letter C. Trying to get x by itself. So again, let's get rid of that plus 9 first by minusing 9 on both sides. So 13 take away 9 gives us 4. Positive 9 and negative 9 goes away, leaving us with negative 4x. To get rid of times negative 4, we'll divide by negative 4 on both sides, leaving us with negative 1 equals x. Because our times 4 and divide by negative 4 went away. Let's check this by taking x is negative 1 and plugging that in for x. So negative 4 times negative 1 is positive 4. 4 plus 9 is 13. So again, this checked out correctly, which means our answer of negative 1 is correct. All right, let's try some more here. Letter D, trying to get x by itself. So first off, whenever I see a minus, I think it's a great idea to turn this into a plus the opposite, just like we did in our last unit. So we need to get rid of this 7 first. Now this is tricky because we see that negative sign there, but this 7 is positive. So to get rid of a positive 7, we're going to minus 7 on both sides, leaving me with negative 3x is equal to 27. Now again, showing all of these steps as you do this work. Next, to get rid of times -3. Notice how this is touching my x. That means we're multiplying. To get rid of multiplying, we're going to divide by a -3. And simplify. Times -3 and divide -3 go away. 27 divided by 3 is 9, but we have a positive divided by a negative. So we'll get -9 for our solution. And let's check this by plugging it back in for x. 7 minus 3 times -9 equals 34. So -3 times -9 is positive 27. 27 plus 7 is 34. So again, this did work. These are equal. All right, letter E. We're trying to get x by itself, so let's get rid of this -7 first by adding 7 to both sides. That'll leave us with 9 plus 7, which is 16. Now we have a divide by 2 in the way of my x. So to get rid of divide by 2, we're going to times by 2 on both sides, leaving us with x equals 32, because divide by 2 and times 2 went away. Let's plug this back in for x. So 32 divided by 2 minus 7 equals 9 is what we're checking. 32 divided by 2 is 16. 16 minus 7 is indeed 9. So we did solve this correctly. X is 32. Letter F. Let's get rid of the plus 2 by minusing 2. X over 4 plus 2 and minus 2 go away. -4 get 2 smaller is -6. Now to get rid of a divide by 4, we're going to multiply by 4. That will be the opposite, the inverse, leaving us with x equals -24, because my divide by 4 and times 4 are opposites. Now let's check it. So wherever I see x, we're putting in -24 as well. That was the solution we found. -24 divided by 4 is -6. -6 get 2 bigger is indeed -4. Let's try a few trickier examples. Now we're going to throw some fractions here. So similar, let's get rid of the plus 1 first by minusing 1 from both sides, leaving us with 1/3 x plus 1 and minus 1 goes away. 5 take away 1 is 4. Now we can think of this fraction as x times 1 and x divided by 3. So let's get rid of this divide by 3 first. We can kind of break this into a couple pieces. So to get rid of divide by 3, let's times by 3 on both sides. So divide by 3 and times 3 go away, leaving us with 1x equals 12. And if we were to get rid of a 1x is just the same as x. So x does equal 12. And again, I'm going to ask you to check this by plugging it back in for x. I'm going to skip that step in this problem. But we would do 1/3 of 12. 12 times 1/3 is 4. 4 plus 1 is 5. All right, this next one here, even a bigger fraction. So we have, let's get rid of -1 first by adding 1 to both sides. That's going to leave us with 3/4 x equals -1 and plus 1 went away. 2 plus 1 is 3. So now let's think of our fraction as two different pieces. Let's think of this as divide by 4 first. So to get rid of a divide by 4, we're going to go ahead and multiply by 4, doing the opposite, the inverse. So divide by 4 and times by 4 go away, leaving us with 3x equals 3 times 4 is 12. Now we have a times 3 we need to get rid of. So we'll divide by 3 to do the opposite. Times 3 and divide by 3 go away, leaving me with x equals 4. We'll check this by plugging it in for x. So 3/4 times 4 is 3, minus 1 equals 2, 2 equals 2, check. All right, another fraction. Let's get rid of plus 22 first by minusing 22. Leaves us with 3/5 x plus 22 and minus 22 cancel out. 28 minus 22 is 6. So let's think of this fraction as two pieces. We have a divide by 5 first that we're going to get rid of. And to get rid of divide by 5, let's go ahead and multiply by 5 on both sides, leaving us with 3x equals 30. Now we need to get rid of times 3. Opposite of times 3 is divide by 3. So times 3 and divide by 3 go away, leaving me with x, which was our goal. 30 divided by 3 is 10. We'll check it by plugging in 10 for x. 3/5 times 10 does indeed give me 6 plus 22. 6 plus 22 is 28, so we will find that we solved this correctly. X is 10. Last 3, and I want us to notice what is different about these 3 problems than the last few we did. And we should see here that we've got a huge division sign under my entire problem here. A big divide by 4. So where in our last examples, we might have seen something like this, where we would have gotten rid of this plus 2 first. But notice this plus 2 is now stuck by this big division sign, so we can't touch it yet. So our first step on problems like these is we need to get rid of that big divide by 4 first. So the opposite of divide by 4 is times by 4. Now when I get rid of this big division sign, divide by 4 and times 4 go away. I'm left with x plus 2 equals 2 times 4 is 8. Now to get rid of our plus 2, we can minus 2 from both sides, leaving us with x equals 6. And still, even though this problem looks a little different, we can still check by plugging in 6 for x. So 6 plus 2 is 8. And then 8 divided by 4 does indeed give us 2. So we solved this correctly. So similar problem here with k. My x minus 3 is all stuck by this big division sign here. So we need to get rid of divide by negative 2 first. And to do that, we'll multiply by negative 2. So divide by negative 2 and multiply by negative 2 go away, leaving us with x minus 3. Negative 1 times negative 2 is positive 2. Now the last thing in the way of x being by itself is minus 3. So opposite of minus 3 is plus 3, the inverse. Minus 3 and plus 3 go away. 2 plus 3 give us 5. So let's go ahead and check this by plugging in x is 5 into our problem, giving us 5 minus 3 over negative 2 equals negative 1. So on the top of our fraction here, if I do 5 take away 3, we get 2. 2 divided by negative 2 is negative 1. So again, we solved this correctly. Last one. Again, we've got a big divide by 2. So to get rid of that big divide by 2 that's keeping x plus 7 stuck, we need to times by 2. When we do that, we have x plus 7 equals 6 times 2 is 12. We need to get rid of plus 7 by minusing 7 on both sides. Plus 7 and minus 7 go away. 12 take away 7. gives us 5. Let's check our last one today. You guys are doing wonderful. 5 plus 7 divided by 2 equals 6. 5 plus 7 gives us 12. 12 divided by 2 is 6, so 6 equals 6. This is true. We checked it correctly. Now, if you ever come to a problem where you get something like 3 equals 7, this is not true. So we would know that we did something incorrectly in our work, and we should go back up to our problem and check it. Wonderful work, you guys.